In lesson 9.1, where we start out by studying geometric sequences, we've already studied one type of sequence this year, and it was for another family of functions. Anybody remember the sequence we have studied this year? If I give you, it's been a little while, so if I give you a hint, it starts with an A. We studied arithmetic sequences already this year. And arithmetic sequences, can anybody tell me anything about a sequence of numbers that if we call it an arithmetic sequence, what can we expect?
Has no upper denominator.
It has to keep increasing or decreasing by the same amount. So it starts at a term and it keeps either increasing or decreasing. We keep adding or we keep subtracting the same amount. So give me an example of like the first four terms of an arithmetic sequence. Make up your own.
4, 8, 12, 16.
4, 8, 12, 16. Okay, they're all going, it's going up by 4. Okay. So if we have an arithmetic sequence actually models a linear function. Okay, an arithmetic sequence is we have a constant change happening that is so like adding 4 in Kat's example, that would be modeled by a linear function. Okay, so let's take a look at what makes a sequence geometric then. In a geometric sequence, each term is multiplied by the same number. You know what? These are kind of good notes to have highlighters for. If you don't get a highlighter that's very good, let me know and I'll give you a different one, okay? So this might be something worth highlighting here, so that when you're taking your final and you are trying to remember what a geometric sequence is, in a geometric sequence, each term is multiplied, not add something or subtract something, but instead multiply by the same number to get the next term. And this number is actually called the common ratio. So we call that multiplier the common ratio. Also known as, I'm going to have us just write this here right now, that is commonly written as little r. Common ratio, little r. Okay, so if we are determining if a sequence of numbers is geometric, what we do is we have to make sure, because what's the undoing of multiplying? Dividing. So if we take a term and we divide by the previous term, that should tell us what the previous term was multiplied by to get that term, shouldn't it? So if we would take, so they're starting here at the end. 54 divided by the previous term, 18, gave them 3. Now take the 18 and divide it by its previous term, and it is 3. Now take the 6 and divide it by its previous term, 2, and that is 3. Do we have anything to divide 2 by? No, because 2 is the first. Will you cover up those highlighters when we're not using them, please? They'll dry out. Because the sequence has to start somewhere, doesn't it? So the first term doesn't have a previous term. So we would say this is a geometric sequence. 3 is the common ratio, so let's write here r equals 3. Okay, this next one, determine if the sequence 5, 10, 15, 20 is a geometric sequence. This kind of sounds like cats. 4, 8, 12, 16. So divide each term by the previous term, the term before it. So 20 divided by 15. Well, that isn't a nice decimal, so we'll leave it as 4/3. 15 divided by 10. Well, that is a nice decimal, but so that we can compare it to that other fraction ratio, 3/2. Well, we could stop right there, couldn't we? Because what? They're not.
It's not geometric.
Yeah, it's not a geometric sequence because they don't have a common ratio when we're doing our dividing. In fact, this one would be a what kind of sequence? This would be an arithmetic sequence, and it keeps increasing by how much? 5. By 5. What did we call that instead of r in an arithmetic sequence? Anybody remember what we called what it keeps increasing or decreasing by? It was called a constant difference or something like that. But do you remember which little letter was in the formula for that one? D. constant difference, D. They used a D for that one, so we were always looking for the D then. Okay, let's take a look at some of the kinds of things you're going to do today. Determine if each sequence is a geometric sequence. Show support. So, we'll start with 4. Let's start at the end like they did and divide by the previous term, 8. Well, let's just simplify that as a fraction. What is that? 1/2. Now we take the 8 and we divide it by the previous term, 16. What is that fraction? 1/2. And now we take the 16 and we divide it by the previous term, 32.
Can we do it that way or no?
You mean start with 16? Yeah, you can start at the front or you can start at the back. Doesn't matter. But you need to show all of them because here's what can happen in some of our sequences. It can fool you. It can look like it's going to be okay, and then all of a sudden it changes. So we would say that this one is geometric, right? And what would we say? If it's geometric, we would say R equals 1/2. In other words, if we started now at the beginning of that sequence, 32, and multiplied by 1/2, would we get the next term? 16. Is half of 32 16?
Yeah.
Is half of 16 8? And is half of 8 4? Yeah. Okay. Let's try the next one then. I'm going to start at the end. What's 32 divided by negative 16? Negative 2. Okay. What's negative 16 divided by 8? Negative 2. It's looking kind of promising. 8 divided by negative 4 is, I guess there is a common ratio then, isn't there? Our multiplier is negative 2 because when we divide, that's what we get. So we say this is geometric, and R equals negative 2. Okay, tell me something, like an observation you could make right now about the difference between these two geometric sequences. In the first one, all of the terms, so far anyway, are positive. 32, 16, 8, 4. Do you think they'll stay positive?
No.
No? What's 4 times 1/2? 2. What's half of 2? 1. What's half of 1? 1/2. And what's half of 1? What's half of half? A fourth. And then half of a fourth is a. Do you think we're really ever going to get into negative territory? Oh, can we? We're multiplying positives by positives. We can't get into negative territory. It keeps getting smaller and smaller and smaller and smaller, but it's never going to get into negative territory. Well, how about this one? Look at these terms. It starts out with a negative, then it goes to a positive, then it goes to a negative, then it goes to a positive. What do you suppose the next term is? Negative. Well, notice the difference between their R values. When R was positive, what was true about all of the terms? They're all positive. When R was negative, what's true about the terms? Yeah, they're alternating, positive, negative, aren't they? Okay, so some of those things are worth observations worth making sometime to see if there's some conclusion you can start making. Okay? Okay, let's look at this one. 8 divided by 6. Well, that's a nice number. So what fraction could we simplify that to? Okay, 1 1/3, also known as 4/3, right? Okay. How about 6 over 4? 3 halves. Oh, can we just stop? Yeah. Is this geometric? No. Not geometric. Well, if it's not geometric, can we give an R value?
No.
No. There's no multiplier. But what is this? What kind of sequence is it? That one's an arithmetic one, isn't it? With D equal to what? 2. It keeps going up by 2's. Okay, and now let's go to our last one here. 0 4/10 divided by 2. So it's kind of like having 40 cents and dividing it between 2 people. How much do you have? 0.2. You get 20 cents. Okay. And then we have that 2 divided by 10. Well, 2 divided by 10, or 2/10 written as a decimal, is that 0.2?
Yeah.
Yeah. And then we have 10 divided by 50. Well, 10/50 isn't that 1/5? And isn't 1/5 0.2 also? Yeah. So is geometric, and our multiplier is what? 0.2. Okay. Okay. Another thing that might be worth observing is, both times our R value was between 0 and 1 when in number 1 and in number 4, these guys. When we had a positive R value, they were between 0 and 1. What's happening to the sequence as it goes to the next term? Is it increasing or decreasing? In both of them, it's decreasing. Does that make sense that our multiplier should be less than 1? It should be between 0 and 1 if it's decreasing? Yeah, it should make sense that if we're taking a fraction times it, it should be getting smaller, shouldn't it? Okay, let's go to the next thing that we're going to talk about. And I'm not going to make you work quite as hard as they did here. If it says find the next 3 terms in the geometric sequence, they're already telling us it's a geometric sequence. They say find the next 3 terms in the geometric sequence. If they say it like this, determine if it is a geometric sequence, and then find the next 3 terms if it is, that's a different story. But this one says find the next 3 terms in the geometric sequence. So in reality, we should only have to do step 1, find the common ratio. We should only have to do one of these. We shouldn't have to do all of them. Because if it's a geometric sequence, they have to have the same ratios, right? Okay. And so now, this part though, we do have to show. 1, the last term getting multiplied by that multiplier, then that term getting multiplied by that multiplier, and then that term, so that we can say the next 3 terms are. So, in the find the common ratio, you get to do 1 ratio. You don't have to do 3 of them. But you do have to show multiplying, even if you're going to use your calculator, show what's going to go into your calculators, okay? So again, this one says, find the common ratio in each geometric sequence below, and then find the next 3 terms. So which 2 terms do you want to use to find the R? 125 divided by 25. Andrew's going to make us work. Okay. 125 divided by 25 is? 5. So R equals 5. Okay, there's our common ratio they wanted us to find. Now we will show taking 120, before you even put your fingers through your calculator. Write down 125 times 5. And if you have to use your calculator, use it. Otherwise, somebody tell me what this is. 625. And then we'll take 625 and multiply that by 5. 3,125. And then we'll take 3,125 because they want the next 3 terms. And what's that? 15,625. But we're not going to write down that whole list. We're just going to circle them. The next 3 terms. Do our next 3 terms make sense?
Yeah.
Why?
Because they're multiplying by the same.
They were multiplying by the same thing. And what else? Josh?
If you take 15,625 divided by 3,125.
Okay, if you take a term and divide it by its previous term, you get 5. What's this sequence doing? Is it increasing or decreasing? It's increasing. Did our numbers keep increasing? Okay, that's a huge observation to make, people. When I correct sometimes people's work on it, and when you're correcting your own, and if you end up with a number that is, you had an increasing sequence, but yet you end up with a number that is smaller than the last term that you were working with, you get a problem. Okay, this one's an alternating. Oh, what did we learn about alternating terms? What's going to happen with our R value? It's going to be negative. Okay, which 2? And somebody else want to pick because Andrew made us work too hard. Josh?
12 divided by -6.
Thanks, Josh. That was a nice pick. 12 divided by -6 is? Negative 2. So our R value equals negative 2. And now we will take 48 times negative 2. And should our next term be positive or negative?
Negative.
Should be negative because 48 is positive. So I think it will be, won't it? What's 48 times 2? 96. So negative 96. Negative 96 times negative 2.
92.
Okay, 192. Andrew was trying to do it in his head. Good job, Andrew. 192 times negative 2.
Negative 384.
Negative 384. Okay, do our answers make sense? We ended with a positive. Our next one should be negative. Our next one should be positive. Our next one should be negative. I like our answers then.
I have a question.
Yes.
Mine have like signs of numbers.
Okay.
You just have to push the on and clear at the same time.
Then turn it back on again. Yeah.
I'll let those guys help you out. Okay. Who wants to pick this time? What are we going to do to find our R value? In number 7. Okay, Andrew.
6 divided by
Oh, you're trying to get on their good side, aren't you? 6 divided by 4. Is that a nice decimal?
4. Yeah.
You know what? If it's a nice decimal, you can use it because look, they're using decimals, aren't they? The 4th term is a decimal. So what is decimal is this? 1.5. So let's use R equals 1.5. There's our R value. And now we can take 13.5, 13 and 5/10, and multiply it by 1 and 5/10. And we're going to put all the decimals, people. Don't shortchange these guys. They want all their parts. And then after you get that one, then do the next one. And then after you get that one, do the next one. And then we'll see if you guys agree with me. Again, I want to see what's going into your calculators, just like I'm doing in our notes. Plus, trust me, you're going to want good notes for the final. You won't have your book anymore. I'm taking it away.
So do we have to write like 625 or do we
Yep.
write it 5, 6?
Nope, write it all. Write it all. They're nice. We don't need to round. The sequence wants them all. It says, give me all my parts. Because if we round, then that will throw the next one off, and then that will continue to keep throwing them off, and we'll never have the actual values of our sequence. Devin, would you pick in number 8 what ratio you want to set up for R?
2 divided by 1.
You are such a good guy. 2 divided by 1 is
2.
2.
I'm multiplying this.
Well, of course, we could have done 1/2 divided by 1/4,
Same.
but then we would have had to, work a little harder. We would have had to change that to multiply by the reciprocal and blah, blah, blah. And so, Devin saved us. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That was easy. Not so bad after all. Okay, so make good decisions about it. When it tells you it's a geometric sequence, and you get to pick which ratio to set up to reach your R value, be wise. Save yourself some work. Questions? Okay, then let's go to our last page where now we're going to find the nth term. So if I say to you, in that last sequence we just did, I want you to find me the 200th term. Are you going to want to have to keep multiplying by 2? Right now we have 7 terms. You want to keep going? 7 times 2 No. Just like in an arithmetic sequence, we were able to take a shortcut with a little kind of like equation that would help us get there faster. If we have the same multiplier going on, what can we do with multipliers? In other words, if I'm going to multiply by 200 times, if I were really actually going to do it 200 times, what's this shortcut way on your calculator to do 2 multiply 200 times? 2 to the 200th power. We can do it as an exponent. We can say, oh, you know what? I'm going to take a shortcut here. I want to, because would you lose track of how many 2's you have in your calculator? You sure would. So there are going to be 2 ways to find it. You can do that. You can be crazy and just keep multiplying by the R value. Or we can use, would you take your highlighters and would you highlight this right here? It's a formula that will help us take a shortcut. And the other thing we want to highlight is what are the parts of this? N is the number of terms. We already talked about R is the common ratio. And we should be able to go off to the side here and remember from arithmetic sequences what A sub 1 means. What is the A sub 1? The first term. So I'm thinking that that's about all we need to have there to help us. So let's look at the one that they did here. They found the common ratio for the sequence. And where was this sequence? Right here. They found the common ratio. They said it was 2. They found that to be 2. R is 2. And then they just kept multiplying by 2 because it stopped at 40. So they had to take 40 times 2. And then they had to take 80 times 2, and then they had to take 160 times 2, and then they had to take 320 times 2, and then they probably had to stop and count to see which term they were finally at. So that would be the 320 is the 1, 2, 3, 4, 5, 6, 7. Oh, not quite there yet. Have to multiply again to get to the 8th term. So how many times did they really multiply by 2? 8 times? How many? They took 5 times 2. They took 10 times 2. How many times did they multiply by 2? Yeah, 7 times. Because they start with the first term. The first term has to be multiplied by 2. And with only multiplying 1 time, we now have 2 terms. So that's why the n minus 1 in the power of r. We don't need to do it how many terms. We have to take 1 away from it and account for that first term. Okay, so let's go practice our number 1 here. A sub 1 is 7. What did they just tell us? The first term. So you know what? This sequence starts with 7. They say that r equals negative 2. I bet you can tell me what the next term is already. Then what is it? What's the second term then? Negative 14. Okay. And let's just do one more. What would the next one be? Negative 28? Positive 28. Okay, so this is kind of like a little snapshot of what our sequence really is with the information that they gave us. But they want us to find the 10th term. So we could keep multiplying by negative 2 until we get to the 10th term. That's method 1. Or method 2, we're going to practice using the formula. A sub 10, remember A sub n, you put for n, we put that we want the 10th term. What goes here? A sub 1 goes here, so what are we going to put here? 7. Start with the first term, take it times the multiplier, the r value, negative 2. Notice how smart they were. They put parentheses around that negative 2. The parentheses are serving 2 purposes. They're showing a negative being raised to a power and that we're going to have to multiply by 7 in the end. And then we put a 10 up here because we're going to have to subtract 1 from that. So we have a sub 10. The 10th term of this sequence will be, do we do powers first or do we do multiplying first? Do we take 7 times negative 2? Or negative 2 times 10 to the negative 10 minus 1 power? Yeah, so let's do this first. Let's just get this to, what is 10 minus 1? 9. So really, then the multiplier -2, if you used method 1, would have to be 9 times you'd have to multiply by -2. So a sub 10 equals 7 times. Oh my goodness, I bet -2 to the 9th power is a fairly nice number. What is it? -512. So in other words, -2 times itself 9 times is -512. Therefore, that first term 7, after it got multiplied by -2 9 times, what would the answer be? Okay, the 10th term is -3,584. Oh, serious question for you. How could we determine if this should be a positive or should be a negative? Make sure that we at least, are on, because isn't this one of those alternating ones? So tell me something about, no, I want the highlighter. Tell me something about the first term. Oops, what is that thing?
All the even number terms are going to be positive and odd number terms. Like
All
the
the-
first and third are going to be positive and the second and fourth are going to be negative.
Yeah, all the odd number terms, the first and the third, they're positive. And then this guy, that's an even number term, it's negative. So the second term is negative. 10 is an even number, right? So the 10th term should also be negative then, shouldn't it? And it is. We got a negative. So we can try and make sense of our answers also. Okay, let's fill in the parts here. We have this one that starts at -4, has an R value of 3. We want the 8th term, so we're going to have to subtract 1 from 8 in our exponent. So a sub 8 should equal -4 times 3 raised to the 7th power. Now, if you want to put this whole thing in your calculator in one swipe, you can, but then you better make sure you get the right answer. You better know how to do it properly, okay? So if you're going to try that, I'm going to show you what you should get for an answer. So you don't want to have to stop and write down what 3 to the 7th power is. You don't have to. But then you better make sure you know how to put in your calculator correctly. Okay? So, did you guys get that?
Yep.
Did it work?
Yeah.
Okay, good deal. Questions? Okay, well then let's move on to this next one that's a little bit, they give it to us a little bit differently. They say the first term of the geometric sequence is 2. What are we going to call that 2? A sub 1. So we're going to say a sub 1 equals 2. Take the time to write this down. A sub 1 equals 2. That's what they just told us when they said the first term of our sequence is 2. And the common ratio is 3. So what are we going to call that? R. And what is the 7th term? What is the 7th then? Our n. Okay? So we're going to say we want the 7th term. So a sub 7 equals what? 2 times 3 raised to the 7 minus 1 power. 2 times 3 to the 6th power. And what do we get? The 7th term is 1,458. Okay. Seem reasonable?
Because they're all even, or not even positive.
Okay. How do we know they're all positive? They didn't give us it.
Common ratio is positive.
Yeah.
Common ratio is positive. It started with positive,
So we can switch.
and it's an R value greater than 1, so will it grow or will it decrease? It better grow. Did ours grow? Yeah. Okay. Okay, and our last one. Be nice if we knew the a sub 1 value. What is it? 5. It'd be nice if we knew the R value. Ooh, I think we're gonna have to find it, aren't we? Who wants to set up our ratio for us? Okay, negative 15 over positive 5. Our R value is negative 3. And what's our N value?
Yeah.
12. Okay, so A sub 12 equals 5 times our R value raised to the 12 minus 1 power. Okay, I want you to just right now, I want you to tell me before we even put it into our calculators, before we even do it, what kind of answer should we expect to get? Considering that this right here is our sequence, we want the 12th term. Should it be positive or should it be negative? Looks like it better be negative. Okay, go ahead and see what happens when you get that one. Whoops. There's what you should get. Did it happen? No. Okay, so those are the kinds of things, along with maybe like an application problem or two in, like I told you, to study example 3 in your book. Those are the kinds, and any other things that you get stuck on, maybe the book will help you with also. And you have a worksheet to do. And I think we should be able to show the work right on the worksheet as long as you don't write too big, but you still have to show the multiple, you have to show what we did in the notes. So you decide if you're going to be able to show that on here or not, okay?